Noble is proud to have operated in Israel, working with the government since 1998, with an excellent record in environmental health and safety. Today, I'd like to share with you some various regulatory structures throughout the world, discuss Noble's approach in working as a global operator, and talk about deep water environmental health, safety, and risk management as we approach it in deep water. Just a brief history of Noble. We were founded by Lloyd Noble in 1932. We are 80 years old. As an independent operator, not a major operator, that is a very long time to be in business. We were one of the first independents to explore the Gulf of Mexico, and we've helped shape the industry and its own future success. We've been recognized for our innovation, flexibility, and our exploration proficiency, technical capabilities, and we've had a very impressive record of success. The company has core operations in the United States, primarily in the western U.S., in the deepwater Gulf of Mexico, offshore eastern Mediterranean, and offshore West Africa. We have an environmental health and safety policy. I'm not going to go through this, but we are committed to environmental health and safety, and this is not just a commitment, this is a culture within Noble. We're very proud to have established this culture, and it permeates all of our activities. Just a few awards that we've received over the years from the Mineral Management Service, from the state of Colorado on the Commission's Outstanding Oil and Gas Operations Award for Environmental Protection and Safe Operation, and in the Gulf for our SAFE Award. And the SAFE Award is an award that's given out for both safe operation and environmental performance in the Gulf of Mexico. Most recently, in 2011, Noble was awarded the first Gulf of Mexico deep water permit to go back to work after the BP incident. So we were the first company that was awarded to go back into the Gulf. I might add that Noble did 2 deep water completions during the moratorium over the summer as well, so we were awarded those permits when others weren't working. I believe Director Bromwich is going to speak this afternoon. I was honored to take a tour on the rig. This is actually the first tour that Secretary Salazar has made to an offshore installation. When Director Bromwich was asked by a number of the press why we received the permit, his quote was, Noble has demonstrated in its application it can drill its deep water well safely and that it's capable of containing a subsea blowout if it were to occur. And this is in comparison to all of the companies in the Gulf of Mexico, including the majors. We also spent some time with the Secretary showing him some new environmentally safe muds that actually we're working with in the Gulf of Mexico that derive from a potato ester. So, a little bit about the major systems in the world. In the UK and Norway, the regulatory regimes and risk mitigation are performance-based, mostly under safety case regulations where the operator identifies the hazards and we evaluate the levels of risk that are tolerable, and then the operator demonstrates the appropriate controls as to how to reduce those to as low as reasonably possible. In addition to that, they do have some prescriptive regulations, prevention of fire and explosion, emergency response regulations, and management administration regulations that ensure compliance and audit and reporting. Also regulations around design and construction. If you go to the US, we have what's considered a prescriptive base regulation. That is based on best available and safest technologies as determined by the Bureau of Ocean Energy Management and Enforcement. They use technical assessment and research programs to provide technical support to the agency, technical assessments, research, and regulatory enhancement. At the onset of the BP incident, during the moratorium, the government started to take a look at where the gaps existed in the regulations. And the drilling safety rule was issued that now considers additional things in well design, construction, and flow intervention of wells. In other words, there were a number of certifications now that are required to drill a well. There are a number of, considering the blowout preventers, you know, how do we get a third-party expert company to come in and certify those blowout preventers? And then what did we learn from that incident as it pertains to containing oil, a well control situation from the bottom of the ocean, as well as responding to oil on the surface. And Noble, and I'll show you in a minute, we apply this drilling safety rule everywhere in the world we work. We don't just apply this in the Gulf of Mexico. We do these certifications here as well. The workplace safety rule is another rule that the government had put in place, and they've given operators in the U.S. The opportunity in 1 year to come up with a safety and environmental management system that's to reduce technical and human and organizational error. The API, American Petroleum Institute, has a model, RP, Recommended Practice 75. Now, again, they've given the U.S. Companies 1 year to develop this. Noble has an existing system that we have used for 10 years, which not only is applicable to this, it's applicable to other jurisdictions throughout the world. So we operate as a licensed operator in the UK. We don't have any operations there right now. Currently, we operate in West Africa, we operate in the deep water Gulf of Mexico, and we operate in the Mediterranean. We've just shown 2 different regulatory regimes. Noble has taken an approach that we are going to look at our risk management in a process of a hybrid of those 2 regulatory regimes. In other words, to be an effective operator, to effectively control environmental health and safety issues, we have to standardize our operations throughout the world. So we have programs where we actually integrate these 2. We do not operate differently in different parts of the country. We have come up with a risk management system and best management practices that actually can rise above what the Gulf of Mexico requires and rises above what's required in the UK and Norwegian systems. And again, this is our hybrid of the 2 systems for goal setting and prescriptive regulatory regime. So how do we do that? Well, Noble has developed, again, what we call our Global Environmental Management Health and Safety System. This guides us. It gives us both guidance on prescriptive standards as they're applicable. It's performance driven. It's consistent under global standards. It's an integrated risk model. In other words, a lot of talk post-Macondo was the operator, the drilling company had their risk model and BP had their risk model, and how are they joined? We actually integrate those risk models, and we do that for a lot of reasons, mostly so that the roles and responsibilities are spelled out before we even go out to a location. So they're defined. This is 14 elements. Just a few additional things that Noble has. I have an audit team that works for me throughout the world. So I have my own drilling auditors that actually go out and audit the operations we have throughout the world. We're independent of the operation system, so that gives us the ability to go out there and if we find errors, it also gives us the ability to go in and correct those. And it keeps our standards where we want them to be. So how do we apply all this to the risk management for deep water operations? I'll talk a little bit about that. One program that we have is what we call our drill well on paper risk assessment. We bring the drilling crews, the drilling contractors' crews, we bring all the third-party organizations working on the well and our people together for a 3 to 4 day risk assessment and mitigation program. This costs a lot of money, but we do it everywhere. We are not required to do this, but it is a best management practice, and we do not drill offshore until we go through this risk mitigation. When we come out of that, we establish roles and responsibilities. In addition to that, we do environmental impact assessments. Even in areas where they're not required, we do an environmental impact assessment. We have waste management plans and discharge management plans, all of which have been given to the government agencies here. And we look at spill response as far as modeling, spill drills, and we use an incident command system to manage all of this. So again, this is our drill well on paper, very extensive risk mitigation. It's essentially an individual safety case and integrates our management systems on each individual well we do. Environmental impact assessments, considerations. We look for and identify potential impacts of drilling. We evaluate and mitigate those impacts. And then we provide our operations with a framework that addresses the regulatory considerations for offshore drilling. Environmental studies that are done, these are examples. We do drilling fluid and cutting studies. We do C4 accumulation studies. We look at spill trajectories, air emissions estimates, air quality parameters. Do we comply not only with international standards, but do we comply with Israel standards? Do we in Gulf of Mexico? We look at effluent discharge estimates, and we look at geohazard survey data that determine seafloor features that could indicate the presence of deep water corals and chemosynthetic communities. We've been known to identify these. We do not want to put our locations in sensitive areas, and or in the case of some areas, you can run a dynamically positioned rig that does not require anchors that can mitigate some of those damages. This is just an example of muds and cutting dispersion modeling that we do. We look at directions. We look at the modeling. In Israel, we are using freshwater drilling muds. In other parts of the world, we use some synthetic muds. Our waste management system, it's prepared in accordance with national regulations, and it's also guided by our best practices. The purpose of the waste management program is to make sure that the waste that comes off the rig is handled when it gets to Israel under Israel's waste management laws, as well as other countries. We also look at discharge management. We have applicable national and local regulations. We also look at MARPOL as a convention, and we use best management practices. These are discharges that consider rainwater, all effluent that may have to be filtered or sent into the sea, that it meets the qualifications to be discharged. We have sampling monitoring requirements. These are not required in many countries, but we have established that we will operate. We do monitor all of this. We actually run mud toxicities, even when we're not required to. We keep the records, and we treat these consistently throughout the world. Oil spill response and preparation. Noble has the incident management system that integrates our response plans. Incident management is it's a command and control situation. Ours is under the United States Coast Guard National Incident Management System. We also operate under an oil spill response plan that has secured access to spill response equipment from response contractors worldwide. I'll talk a little bit more about that in a minute, because we have to integrate our response plan into the country of Israel's plan. And we provide, the plan provides guidance to the incident management team. We have a team here in Israel. We also have a team in Houston on response and management of the offshore spills. We have run a number of drills. I'll show you some examples of that in a minute. This is just how all our plans tie together. Methodologies for spill modeling. We look at wind, current, polluting, forcing issues. We look at surface and subsurface modeling. We look at the identification of shoreline features. And surface modeling gives us trajectories that's combined wind, wave, and currents at the surface will give us the trajectories. In the Mediterranean, it's very important to look at that seasonally, because the trajectories can change throughout the season of drilling, so we watch that. Our environmental analysis, we look at the location of the well, what are the coastal features, where are the sensitive areas, what are the ocean currents, and what are the wind patterns. So not just locally, but again, we have to look at all of this for the period of time that we will be operating in an area. We look at shoreline features. You can see the diagram on the right. These are identified shoreline features in Israel. We also look at the available equipment and response equipment that is within the country. Ocean currents, wind patterns, again, this is a 365-day, a year look. We can't just do a snapshot. We have to monitor the weather, currents, and waves to know where to respond. Some hydrodynamic modeling. We just look at currents in the area. There's been some theoretical modeling done for subsea, very little current on the bottom with a usually very high velocity flow at the surface. This is, we did a spill response drill in January of this year, and we conducted that response equipment training and deployment drill out of Haifa. It included the personnel from Noble and our local responders. In addition, our international responders, our oil spill response out of UK and Sea Corps out of they're out of the US, and they have operations in Africa. One of the things we identified when we looked at this is the sensitive shoreline of Israel. And we inventoried very early what boom was available to protect the shoreline. And we have actually brought in additional equipment in, and we call them sea vans that come in, and we actually have dispersant deployment equipment, we have additional boom, and we have tactical strategies that we have developed just specifically for working here. And as you'll probably hear Director Bromwich talk about subsea containment, the U.S. has developed two systems, actually. Noble was very instrumental in helping develop one of the systems. There's a system that's being developed in the U.K. This is a system that's being developed that we're talking to Wild Well Control, which is a company out of the U.S. This equipment actually is on the ground in the U.K. It's being made deployable via aircraft, and will be ready shortly to be deployed anywhere in the world.